Great. Thank you, everyone, for being here. In stark contradiction, and we'll try and do a lot of contradiction on this panel, is what we discussed about. In stark contradiction to what Shakespeare says, old is truly not gold, right? And especially in big data. You know, the Cowen group put together a random survey, and they saw that in 2 years, Oracle and Teradata fell out of being the top 10 vendors for the future when it came to data. So something huge is a shift. And to make that come together, I'm delighted to have such a distinguished panel. And what we're going to talk about specifically is how is the old giving way to the new, and why is that? And to start that off, you know, I'd like to ask the panel members a question. If you could ask your data one question, what would it be? And how would you get it out of those systems?
Start with Deepak.
So I guess the beauty of my job is that I can ask multiple questions to the data every single day. If that was not the case, this won't be such an exciting job. But since I'm supposed to comment on one question, maybe I'll comment on the question which I ask my data every single day when I go to work, which is, given the millions of users who are going to come to LinkedIn, what is the best thing I can show to these users so that they become better at what they do? How do I show things that is going to create new economic opportunity for everyone in the world? So for instance, Amol from India, who is a new MBA graduate, what jobs should I show to Amol when he comes to LinkedIn so that he gets off to a flying start to his management career? Mary from Miami, who is a budding fashion designer and just got her first job, what news should I show to her so that she could keep up with what's going on in her field? Andrew, who's a new PhD graduate student, just got his first startup job. How should I help him nurture his network so that he can get a better job or better opportunity in the future? How do we help people connect with each other so that we drive more value to the ecosystem in the long run? How do we help companies market their product and increase the reach to the professionals who are there on LinkedIn? So these are the kind of questions that I like to ask my data every single day, and it's not an easy task. There are two things that has to happen to make it work. One is relevancy, the second is scale, right? So relevancy is what you can drive by looking at patterns in your data. Based on all the data we have seen in the past, I should be able to say what users like Mary, what content have resonated with users like Mary in the past, and then give Mary the same kind of content when she comes to the site. Scalability is important for automation, right? So at the end of the day, it is about mining disparate sources of data to drive relevancy at scale. Right?
All right. So I'm more of a systems person than a scientist, and I think my answer will reflect that. So the sort of two questions I really look at is, where did this data come from, right? Is it accurate, and can I reorganize it? So this is one of the real differences and real impacts that we had at Yahoo by bringing Hadoop in as a system, right? We could keep all of the raw data. And that meant that when somebody believed that there was something odd with our fraud algorithms or similar sorts of things that were very important and used early to clean the data and process it, they could go back and look at all the raw data. They weren't limited to looking at the aggregates. They could always drill down and drill back all the way to, you know, the raw events that happen in the system. And that's something unique to these big data systems, because most data systems lose data at every step of preparation. So by the time you're able to ask a question, you know, so many decisions have been made and assumptions are made that often the right data isn't there to answer your questions. So that's, you know, where did you come from? And in terms of can I reorganize it, again, the power of some of these big data systems is that you're not dependent on the system administrators and the sort of data maintainers to decide how the data is indexed and organized. You can literally pick up 10 terabytes, 100 terabytes of data and reorganize it. Maybe it's organized by time and you want to organize by user, by session, right? Those kinds of things were, you know, large IT projects in previous systems. But with these new data systems, this is something that a user can do to prove the value of an idea. And that allows innovation to happen much more quickly because you can argue about a project from proof that it'll add value.
Great.
And my answer is a little bit more personal. I've done a lot more stuff on the consumer side. So I would say, ideally, if big data works, then I'd like to be able to ask questions that, given my activity level and lifestyle, when am I going to have a heart attack? One of the important questions that South Asians always think about. And the reason I sort of talk about it is there are, typically with big data, and this used to be true with analytics as well, is there's a framework called data, information, knowledge, and wisdom. And what a lot of the big data, and to a certain extent some other things are doing right now, is giving you a lot of data, a lot of maybe enough information, but the wisdom is where the nirvana is, right? And that's where some of the things that are important to us in day-to-day life matter. And I think wisdom is not something we have gotten to yet. So I would like to ask anything that is along the line of, not whether the day is hot or cold. It's more along the line of, when do we think temperature would be at some point significantly higher on a consistent basis than the normal?
So it sounds like the old systems, the traditional systems, are truly toast. Given the use cases that you all are talking about, what are some of those aspects of discovery analytics, time-sensitive analytics that you all are using in your day-to-day lives that might be requiring a whole new way to look at systems and the big data platforms as they come along?
I think the thing that is amazing is that sensors is with us all the time. It's a smartphone. It has so much information, and we are adding more and more sensors on top of us. So there is so much data, whether it's location, whether it's your activity, whether what you're doing, and if you can really awake the listening ability, so create always on Siri, or being able to give it eyes, which is keep your camera on all the time so it captures everything that you're doing on a given day, then that's even more data. And how do you actually take some of that data and do it? Because sometimes you ask a question along the line of, I can't remember that conversation I had with you, 3 weeks ago, but we talked about something interesting. And I wish you have your smartphone, I wish I could just tell it then, go back to the calendar, find this conversation I had with Deepak 3 weeks ago, let's actually hear what we just talked about.
Yeah, similarly, the thing that's amazed me about the Hadoop project and other sort of recent big data technologies is just the economics. You can keep all this data. You can, do less with a lot more data in a sense of just keeping it and going back when you understand what questions you're going to answer. And that lets you, instead of, again, pre-deciding what you want to do with this data and discarding most of it, you can do less up front and then come back when you know what the questions are you want to answer. And you have this treasure trove. A thing that we talked about a lot in a science panel I was on, a few years ago now, is just that, big data and data is really transforming how science itself is done. Right? It used to be that the person that controlled the instrument was the person who made the most important discoveries. If you had the telescope and you got to choose where it was pointed, then you were going to make the discovery. Right? Now, everybody gets to see what happens. They've got these telescopes that sweep the whole sky every day. All right? So the person who does the best analysis on the data that's captured and shared with everyone in the world is now the person who does the discovery. So that's the kind of transformation we're seeing. Right? It's very exciting.
Yes, so my background is in statistics. I have been a statistician all my life, and the number one thing we used to learn in statistics 15 years ago was how to generalize from small data, right? That was really the paradigm, and the entire theory of machine learning and statistics is kind of based on that fundamental paradigm. Today, that has turned upside down, right? We have so much data. What do you do with that? And so all the theoretical developments that have happened in these fields have to be completely rethought. And I see that every day in my work, right? So in the space of recommendation, every single pixel on the website can be filled by multiple choices. You have thousands of choices and you have to select one of them. And that involves doing a large number of real-time computation. And of course, you have to do these computations very quickly because otherwise the page is going to load very slowly. And so in order to scale such computations, often there are different computational strategy one has to adopt. So there are some computations that can be done offline, like using Hadoop, to understand stable patterns in the data. So people in San Francisco like baseball news, right? That's a stable pattern, which you can compute offline. And that is supplemented by some near real-time computation. So, okay, Peter, he lives in San Francisco, but I've shown him baseball news 30 times, but he doesn't like it. So that's an idiosyncrasy which you have to adapt to in near real time. And then finally comes the real-time computation, which you have to scale and serve the page in a few milliseconds by using clever information retrieval and systems technique. So this whole thing requires a complete rethinking of how we do computation.
Right. It also seems that science is trumping art when it comes to decision making, right?
Yes,
And
yes.
where do you see the evolution of big data when it comes to not requiring so much human intervention? Because when iteration is required, you need to be able to do that in software. So software allows you to do that very fast, obviously running on modern hardware as well, instead of proprietary pieces of appliances that are out there lately.
Yeah, so I think the human loop, we are not in a position today where the human can be out of the loop. But what we can do is by developing better software, we can make the life of the human better, and they can concentrate more on the problem formulation rather than struggling with software, right? So for instance, again, in my area, for instance, one fundamental question is, what is it that you are optimizing for, right? So generally, if you look at recommender systems, people generally tend to optimize using machine learning, things like click rates and explicit feedback and so on and so forth, but that is not really optimizing the long-term business value, for instance. And if you look at today, we are so much ingrained in optimizing that solving that myopic optimization problem, we don't actually spend a lot of time thinking about those hard problems. So what I imagine is as software will become better and robust, and what we are struggling with today becomes tool, similar to what Hadoop was like 6 years ago. It was not very easy to use, but today it's very easy to use. As that happens, we'll see more and more data scientists working more on the formulation of the problem and solving the hard problems and kind of taking these as tools and doing it.
So it is about artificial intelligence or augmented intelligence? Because that iterative nature, maybe Mehul, you can talk to it. What's your thoughts?
Yeah, so that's where I think the biggest challenge in what you talked about is that if you throw a machine at a set of data, it's more than likely to find hundreds of correlation. But which one of those hundreds of correlation actually has a causation built into it? That's a real question, right? And that's pretty tough because there is a good chance if you do that, there is a correlation between traffic on 101 and my health going down. Like, all these random correlation can completely come up, and what you really need is to identify 4 or 5 that you think has a potential causality built into it. And that's where humans are necessary because they understand the context way more than computers. And then you can narrow it down to 1 or 2 points that might be an answer. So, and then that's where most of the successful big data / machine learning companies are there, and Palantir actually is one of the better examples of the company that is doing augmented intelligence very well on unstructured data.
Eric?
I don't think I have a lot to add to that other than that we're just building infrastructures that let you keep much, much more data in sort of millisecond access rate so that you can make much more informed decisions. And a lot of what we've seen in, for example, Yahoo, we're using Hadoop a lot, is an ever-tightening loop where we're building models about what people want and then putting those into systems that can serve them instantly. So we're just all the time providing systems where there's more compute available at the time of the question and there's more data available at the time of the question. And that's exciting in terms of us able to do richer things in real time.
But as one of the founders of Hortonworks, talk about the new foundation. What's needed with the new systems? What did you think about? Why was the old system not really meeting the needs of today's data needs? What were things that you thought through when you were building this real good institution?
Well, I mean, in some ways, it's giving us too much credit to say thinking through. It's a lot of ways Hadoop was sort of invented in a series of trials, right? The original goal was how do we process a web's worth of data, just a huge amount of data. So it was really driven by economics. We want to be able to store orders of magnitude more data than we can with the traditional systems. So one of the clear shortcomings was just price effectiveness, right? So Hadoop is focused on using absolutely commodity gear and engineering those systems to work provide a reliable system instead of building a system out of expensive, reliable components. So one of the failures was just sort of cost effectiveness.
Right.
And then the other was just, as I said, scale, right? We got to deal with so much data, right? How can we, how do we think about building a system that can do that?
So what's the role of MapReduce? We had a pretty active conversation just in the prior session here. MapReduce is, some people said dead, but there is also the whole idea of SQL, the lingua franca of analytics and BI. What's the role of SQL on Hadoop?
Oh, we're seeing a lot of SQL used on Hadoop. There's really, when you look at, I would not say MapReduce is dead. What I would say is that, Hadoop has become a much richer platform over time. It now has a layer called Yarn, the resource manager, that will let you run MapReduce or many other kinds of computational frameworks. SQL has been implemented on top of MapReduce. We're now seeing new SQL engines, which are much faster and more efficient, that bypass MapReduce, right? And there's 3 or 4 different companies taking 3 or 4 different approaches to that problem. But the exciting thing is, we have these streaming frameworks that deal with digesting huge amounts of low latency millions of events per second we're seeing now is fairly common, which is an amazing sort of volume of data, right? And then we're seeing these in-memory iterative frameworks like Spark that are great for machine learning, and then we're seeing these dedicated SQL engines that are good at sort of point lookups and specifics. So there's a broad set of solutions where before we just had one hammer. Right. So that evolution is obviously very exciting.
That sounds great. And Deepak, any new use cases that come out of this, and your thoughts from a recommendation engine?
Yeah, so I think it's great to have these set of toolboxes now, because different applications require different ways of processing data. So like in the internet, as far as I'm concerned, we work with very high frequency data, and I'm sure many of you also work with high frequency data, where there is a need to keep processing this data very quickly so that you can adapt. Otherwise, you're not. If something happens in the world and you're divulging that news to the users 2 days later, then you're dead, right? You're not going to be germane anymore. But there are many other areas where it is not important. Like, if you're doing clinical trials or if you're doing bioinformatics, you don't need to process data in real time, right? You can actually take the data, do your analysis, and after a month you go to the biologist and kind of come up with a new discovery. That's actually great, right? So there, maybe you don't need all the high frequency data processing which we need for internet data, right? So it really depends on the application. Right. And so we should not be putting the cart before the horse. We should be looking at the application and then deciding on what tool to use in a very cost-effective fashion.
Mehul?
Yeah, it actually, and you hinted this a couple of times. So one of the most interesting thing we did was we obviously had quite a bit of data to do gesture recognition and machine learning. At some point, we had I think 30 to 90 days of continuous video data. So that's a large chunk that we used. But once we started training the model, what we realized is that if you actually figure out a way to structure that data and seed a system, just like you sit in front of a little kid and say, this is A, this is A, this is A, and then they finally get it. It's the same exact example. Once you seed that data, then quality actually matters more than quantity. So for us, as it turns out, once we built our system and once we got to the point where the algorithm had certain efficiency, we can probably build a new gesture with 50 images, as long as they're qualitative. And that's actually fairly surprising in a reverse way. And it's good that it's this way, because other important aspect, at least on the consumer side, is with data, if you have to go to cloud to go do processing and come back, which happens with Siri, every time you say something, it goes to the clouds, comes back and gives you an answer, it's already too slow for you to actually make sense, for you to actually make it better. So instead of waiting for that transaction to happen, what you do is you just do search in a normal way. And then that's where the latency in some of these things become important as well.
Great. Well, given all the entrepreneurs in the room and the success each one of you have had as entrepreneurs, talk about how people should think about big data. What's changing in their companies? How should they make investments in the future? What are some new ways of thinking that big data is enabling? We've got about 5 minutes. You turned the clock, but that's what it is.
Yeah, so I think big data today is a competitive advantage. If you have 2 companies doing the same problem, I would invest more in the company that is going to be more likely to be successful in handling big data, because that is a competitive advantage. I would also invest in companies who are building tools to solve some of the big data problems, right? And so today, given the big data revolution, we are able to solve some of the toughest problems of our generation by using big data. We don't have to invent a theory of relativity to solve these problems. We can actually empirically solve these problems. I mean, that's actually a great situation to be in. So we should build tools, but at the same time, in my opinion, I think, again, this is preaching to the choir. At the end of the day, we should not put the cart before the horse. We should always figure out what these tools are trying to solve. What are the big problems we are trying to solve, and then invest accordingly.
Yeah, I mean, one thing that becomes very obvious when you work with a number of companies and their big data problems is that within every industry, within every vertical, there's a vast difference in sort of ability to absorb this technology. And you see companies that are way out in front and have already sort of learned how to use these techniques and are taking advantage of them. And then you see sort of a vast middle that's exploring this in a competent way, but hasn't really put it into production. And then there's a tail of companies that just aren't going to get there without a lot of help, right? So, you know, if you own a company that has data problems, I would encourage you to really look at this. And in terms of investing opportunities, I think there's a huge opportunity in every vertical to really build services, to build new big data applications, right? I think if you look at the last few years of the sort of big data industry, there's been a lot of sort of focus on building infrastructures. I think at this point the infrastructures are satisficing. There's years of innovation to come, but the APIs are understood well enough that I think the real innovation over the next few years is going to be solutions, bringing finished products to companies that help them see ROI immediately. So I would really encourage people to, you know, pair up with people that have a domain-specific knowledge base and build big data tools that can be taken to companies.
Actually, and some of the thing is it's not just new tools, it's actually new generation of tools which are simpler over to use on web. And perfect example of this is, you know, company that I'm very well familiar with is a company called Optimizely, which is essentially simple way of doing A/B testing. And in Valley, A/B testing seems such an old thing to do. We should be moving on. But then once you step out of the Valley and you realize what the world is, you know, A/B testing is something that most of the industries are still just starting to grasp. And that's where companies that are actually taking this basic concept and simplifying it so that it's accessible by even a small business in a very simple manner, and they can set it up and get an answer, which is a finished product now. That's actually very valuable.
Let me just second that, because that's exactly what we were doing at Yahoo, and this is just an example of taking that to a much wider audience.
Exactly.
That's great. We're nearly out of time. So just to summarize, think about business outcomes before you go in and start investing in big data projects. And think about next generation platforms, next generation tools that allow you to give that scale, the relevance, the accuracy, the discovery analytics, and the timeliness of getting that analytics out so that you can make the right decisions. I'd like to thank the panels and thank all of you for attending the panel here.